Go to the parlor. Go to the parlor. You guys are all welcome. Make sure you take your seats as usual. So we have these charts. Now this chart is very, very unique. It's a very, very unique chart that we use in explaining all the chemical reactions of a thing. Remember, if you have any question, ensure that you use the chat section and we will be glad to entertain your questions. All right, so let's talk about this reaction chart. For me, this is the best of the best for now. Okay, so I would have preferred to show you videos and of all these reactions, but with this chart, you will not miss out on any possible reaction. Take notes. So what I'm going to do, I've already sent these notes to the WhatsApp group. I want to believe that you all have it. So what we are going to do, our activity for today is that for every of the reaction, their products. So we will try to name the product. So please ensure that you get your pen or screenshot it so that you can also get to know the names of these products, because this chart does not show the names, only the structures of the products. Now, first of all, this is my ethene. This, whatever you are seeing here, okay, that's my ethene molecule. Now, this ethene undergoes different kind of reactions. So the first one we'll look at is combustion. Combustion here shows that it is combining with oxygen. You can see the reactant heat, excess oxygen. So you can see the product carbon dioxide and water. When you combine with excess oxygen, you see the product carbon dioxide and water. If you combine it with limited oxygen, you can see here we have coke, which is carbon dioxide, and water. You can see this same setting. It combines with, if it is combining with excess oxygen, you give carbon dioxide and water. If it's combining with limited oxygen, we have carbon dioxide, carbon oxide, water, and coke, as I tell. Now, another reaction it undergoes is addition. So I'm going to talk about, take note of all these ones here are addition reactions. All these ones are, so I've labeled them. All these three arrows are addition reaction. Even this one is an addition reaction, but we try to call it oxidation. Okay, so this one is also addition. So all these ones are all addition reactions. Now the secret thing here is that what are you adding? This is addition of hydrogen. See the reagents here. Addition of hydrogen in the presence of a nickel catalyst. This is hydrogen here. Addition of hydrogen with nickel catalyst. This reaction is heated at 180 degrees. So nickel there is a catalyst. So you can see, what do we get? Ethene, we have the first name here, ethane. So take note, this is ethane. I don't need to be writing it. So this is ethane. So I'm dictating the name. Addition of hydrogen to ethene will give us ethane. So the double bond is broken. The second one, addition of bromine. Now remember what I told you was one of these, that it is the functional group that is our reaction center. The functional group is our reaction center. So it's at the double bond that the addition takes place. Look here, I'm adding 2 bromine here. I cannot add it to 1 carbon. I cannot add it to 1 carbon because it is the double bond is shared between the 2 carbon. So the double bond is your reaction center. So you add one of the bromine to one of the carbon and the other bromine to the second carbon. So take note of that. It is the reaction center that this addition takes place. So under the addition of bromine, addition reaction for bromine, do we need? Yes, I told us earlier on that tetrachloromethane, an alkane, is an organic solvent. So for this reaction to take place, you must dissolve the bromine. You must dissolve this bromine inside tetrachloromethane, CCl4. CCl4. So CCl4 is a suitable solvent for this reaction. Okay, then we have hydrogen bromide. Okay, that's another addition reaction. So, let me give the name of this compound here. This is 1,2-dibromo. 1,2-dibromoethane. 1,2-dibromoethane. Here we have only one bromine, so that means it's on the first carbon, so that becomes bromoethane. But here bromine is on the first, bromine is also on the second, so that becomes 1,2-dibromoethane. Okay, then there's another additional reaction here. This is called hydration. Addition of this is one of the this reaction will take place at 300 degrees Celsius, 60 atmosphere, and in the presence of phosphoric acid catalyst. So this is a reaction condition. Please take note of that reaction. So the reaction condition for hydration, addition of water. This water must be in form of steam. That is one of the method of preparing alcohol in the lab. Hydration of ethene. So the condition is 300 degrees Celsius heat, 60 high pressure and high temperature, and presence of catalyst. Then finally, so let's get into the name of this one. This compound is called ethanol. Very simple. So this compound is called ethanol. Then the next compound I want to talk about is here. You can where we are. Yeah. This is what we call oxidation reaction of ethene. Oxidation reaction of ethene. Now during this oxidation reaction, is use an oxidizing agent. See, a very strong potassium permanganate is a very strong oxidizing agent. So you can imagine cold acidify. Look at the word there. Cold acidify. What does that mean? It simply means dilute. The acid should be dilute and not concentrated. Okay, that's why we are. So you add dilute acid. So don't forget. That's why it says cold. It's not hot. If it is hot, it becomes concentrated. But here we are saying dilute. So we have to, in the case of, say, instead of using cold dilute acid, we use cold acidify, which is still okay. So the name of this compound, you see it in wire pass 2008. So let's get to name this compound. Okay, let's name it together. It is an alkane, but it's an alcohol at the same time. The carbon atoms are joined together by a single bond. So it's called ethane. I'm calling ethane 1,2-diol. Ethane 1,2-diol. Ethane 1,2-diol. And finally, the last reaction for these alkenes that I want us to pay attention is the baba of the babas. This is one of the most important reactions of an alkene because we use it to produce a polymer. We use it to produce a polymer, and that polymer is called polythene. It's called polythene. I don't call it nylon. No, please. No, it's not when you say, because you are in Nigeria now, you're not saying nylon in the exam. You will not be saying it's nylon. It's not nylon. No, it's called polythene. Can you spell polythene? Obviously, I trust you. Polythene. The other person will spell this Polyethene. You are still saying the same thing. It's just English spelling. So this is most important reaction of alkene. Why? Because this alkene is converted to a series of multiple chain, which is called a polymer. So this is called a polythene. So what is the reaction condition? I mean, I like talking about reaction condition because they are not writing the exam said by Mr. Kocha. So it's important that you take note of that. So here we have additional reaction condition. Here is high temperature, high pressure. High temperature, high pressure. So you can see The conversion of ethene to polyethylene, which is what we use in making plastic. That's raw. Ethene is a raw material for plastics. So polyethylene is an example of plastic. Take note of that. So they also have polyvinyl chloride and other plastics derived from ethene. If you have any question, please put it on the comment section. Put it on the comment section and you will never regret being part of this session of chemistry. Okay? So now, but I think I cannot remember all these things that you just said now. I've made it easy for you. Each of the slides, yes, this is the slide for the combustion reaction. Remember? So this is the slide for the combustion reaction. This is the slide for addition of hydrogen. So that reaction is called hydrogenation. Addition of hydrogen is called hydrogenation. I've already explained to you, it's nickel catalyst, and hydrogen is also a reagent. Okay, we have another one, halogenation, addition of a halogen. Somebody says, excuse me, that if we add chlorine, should we call it chlorination? No, sir. Don't call it chlorination because I did organic chemistry. You can call it halogenation because it's a halogen. Because you cannot add fluorine and not call it fluorination. No, 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 no. Or bromination. Please call it halogenation. All right. So the next thing I want you to know here is that this bromine is usually brownish red in color. When it reacts with this ethene, it will be decolorized. It will be decolorized. So this is a way to defluorination of bromine. All right. So the next thing I want you to okay. So take notes of that reaction. So we said here it is the decolorization of this bromine that will show that that reactant is a double bond. The decolorization shows that the reactant contains a double bond. So you can see the product formed. Then you have the other one, addition of bromine water. This is another one we can talk about. Addition of bromine water is also another way to differentiate between an alkane and alkene. So you see decolorize the reddish brown color of bromine water. Okay, then I have another one, hydrogenation, addition of the hydrogen halide. Yes, this is this one usually comes as an objective aspect of chemistry question. Okay, so what do we need to take note of? Now take note of this. Hydrogen goes to one of the double bonds, while chlorine goes to the other carbon of the double bond. Okay, so that's what we have here. Chloroethane. Okay, very easy to talk about. Well, I can ask you to draw the structure of this compound, and you'll be happy that you learned it for me. Now, there's one specific rule. Now, in some cases, there's what called unsymmetrical alkene. Like what we have here is a symmetrical alkene, whereby we have two balanced carbon atoms. Two balanced carbon atoms. What do I mean by balanced carbon atom? You can see the carbons of the double bond. The carbons of the double bond, these two carbon here, all contain equal number, contain two hydrogen respectively. So this is what we call a symmetrical hydrocarbon, a symmetrical alkene. So the carbon of the double bond contain two equal number of hydrogen atoms. So that's why I call it symmetrical. But if it becomes unsymmetrical, what do I mean? They are no longer equal. Let's say, for example, look at this one here. This is an unsymmetrical hydrocarbon. You see, these two carbon are the carbon containing the double bond. So this is an unsymmetrical hydrocarbon. So you can see this carbon contains two hydrogen, while this carbon contains only one hydrogen. So the question is, where will the hydrogen from this hydrogen bromide go to? So first of all, now hydrogen law, there's a common atom effect. So the hydrogen will kindly go to this first carbon that has two more hydrogen atoms, while the bromine will go to this second carbon that has less hydrogen atom. So that law is known as the Markov-Nikov's rule. Look at it at the top of the scale. Markov-Nikov's rule. What does the rule? It says that when we have an unsymmetrical alkene, the hydrogen goes to the carbon of the double bond that has more hydrogen atoms, while chlorine goes to second carbon that has less number of hydrogen atom. So I ask the question, does it mean it's not possible for the hydrogen to go to the second carbon? It's not possible, my brothers and sisters. In chemistry, we don't say there is anything called impossible. So we said the chances of it occurring, the yield. There's a word I'm going to introduce you to, maybe yield. Let me type it. Yield. Yeah, we call this yield. Yield is the amount of product formed. So this yield of this product that we have here is usually very high. This one here, the yield can be like 98%. While the other one that contains hydrogen, the second carbon, can be like 5% or 2%. So that simply means that it will be too stressful. How can you want to imagine you want to fry dodo after you finish slicing the plantain? A whole lot of plantain gets burnt every time. Only a few pieces is left. We do want to continue that process. That's waste of resources. So that is why we say that based on the Markov-Nichols rule, why could be expecting you to state this one that has a higher yield. So please don't forget, the reason is because this one has a higher yield while the other one has a lower yield. Okay, so the lower amount is produced. All right, we have 5 minutes. Then this is the oxidation, like I've already shown you here. This is another reaction that we use to differentiate between alkane and alkene. Then polymerization, like what you have here. You can see when I told you the numerous alkenes. You can say this is an alkene, this is an alkene, this is an alkene, this is an alkene. So they added. So during the process of adding, this carbon connects to this carbon, this carbon connects to this carbon, this carbon connects to this carbon. My brothers and my sisters, what are they using carbon to connect? The double bond. They use that double bond to connect to each other. So they use this double bond to connect to this. So the double bond is broken. So that's why you can see here that the double bond is being broken. And by the time you see the finished product, it does not contain, this is the finished product, it does not contain any double bond anymore because what? Polymerization has taken place. So we say the free bonds link with one another to form a chain. Okay. I think I have something I still need to show you on this slide. Let me see. Okay, so I think I put the conditions here. Yes, this is why I put the conditions so that you don't forget. Molecules of 18, with the conditions that be high temperature, high pressure, and sometimes high presence of catalyst are three major conditions that you must take note and remember. Okay, then which other thing? Do I have another thing on this? Yes. Okay, this is just for girls. Then this is just to distinguish between an alkane and an alkene. You use bromine water. So if it is an alkane, you can see addition of this bromine dissolved in tetrachloromethane. I told you. If it is alkane, if it is an alkane, you can see the bromine water is retained, the color is retained, but for an alkane, it has decolorized. It's no stress. You guys are the boss. All right, so I hope I've tried my best not talking to myself alone. You have an activity here you can use to refresh yourself, ask yourself question, do I know this? Do I know that? Okay, and yeah, you must be ready to go. So should we try this? Because we have 2 more minutes to the end of this session. Unfortunately, I could not hit my target again. Somebody say, let me see what the question is saying. Somebody says, thank you, sir. All right, you're welcome. So let's just try this. This is 18. You can see here, 18 is converted to this kind of thing. That's a polymer. That's a polythene. So remember, this is stage 4, addition of chlorine. This is an addition reaction. What is this one? Stage 5, subtract. Carbon is 2. Carbon is 2. Hydrogen is 4 here. Hydrogen is 6 here. That means there must have been an additional hydrogen. So that means it's an addition reaction. Okay, so the glucose is converted to ethanol. That's called a fermentation. Ethanol is converted to an 18. I call it dehydration. I hope you've not forgotten at the beginning of the session. All right. Do you have anything thing you have here. State the reagent needed for stage 2. What is stage 2? Where is stage 2? Yes. What reagent did you use here? Concentrated tetraoxosulfate 6 acid, that's H2SO4. That was the reagent needed in stage 2. What is the reagent needed in stage 5? Hydrogen. You can see. What is the name of the product formed in stage 4? Where is stage 4? Where chlorine is added. So 1,2-dichloroethane, that's the name of the product. 1,2-dichloroethane. What are the conditions required for stage 3? Stage 3 is the polymerization. So what are the conditions? Well, remember, high temperature, high pressure, and catalyst. Say give the names of the processes in stage 1, 2, 3, and 5. Stage 1, conversion of glucose to ethanol. We call it fermentation. Your fruit juice being converted to alcohol is fermentation. Then stage 2, ethanol converted to ethene, dehydration. Stage 3, the ethene converted to polyethylene, we call it polymerization. And stage 5, hydrogen added to ethene, we call it hydrogenation. Ladies and gentlemen, we have exhausted the time for today's session, and I hope you have learned some new things you can talk about. I'm not coming back to talk about alkenes anymore, but don't forget, ethene is used in the ripening of fruit, and it is also a raw material for plastic industry. That is actually WAEC number 1 question of 2019. This raw material for plastic industry. So, all right. Do I have any more? Yes, alkynes. I'll be talking about alkynes in the next class. I feel like alkynes should not be an issue, but WAEC has not been bringing alkynes, just their functional group. So on the WhatsApp, we can, if you feel we should talk about alkynes, you can put it on the WhatsApp. So we can talk about alkynes and benzene. I don't know whether this organic chemistry is taking too much. I hope you guys don't get bored, but I'll try and make it easy. Alkynes and benzene. Then now we talk about alcohols and carboxylic acid and esters. And I believe ourselves we will do justice to it. So, ladies and gentlemen, I want to believe it has been a worthy time with all of you. If you have any question, if you have any topic you want me to talk about, if you have any topic you want me to talk about, you can simply put the topic on the WhatsApp section. Don't be shy. After nobody knows you. So just put the topic on the WhatsApp section, whether it's SS1, SS2. You can take a break from organic, do the topic, then come back, to the organic chemistry. I remain your able host for this chemistry session. Have a wonderful day. Okay? Goodbye.